there's a EMF of 20. Why are you smiling? Hey, pay attention. Okay, there's a battery with EMF 20 volt, internal resistance 2 ohm, current 4 ampere, and there are two resistors in parallel. Right? Okay, so in this case, can you find the resistance R1 and the power supply to each of the circuit components? That means both for R1 and R2. Okay, now how to approach this question?
Can I use Ri equals to V?
Ri equals to V.
Yeah.
Okay, then can you apply what you learned just now? That is, in any closed loop, the potential rise must be equal to potential drop. Okay, that means what? You can take any closed loop, right? Okay, can you take the loop between the battery 20 volt, R2 and to the 2 ohm, ignoring the R1? Is it possible?
I don't know. Is it possible?
By principle, is it possible?
Or closed loop? Okay, that means
Yeah.
closed loop means we can ignore R1.
Yeah, because from the battery back to the battery, right, I can pass through R2 without passing through R1 and go back. So there's a closed loop, correct? So what's the potential rise for the closed loop for that, including R2?
Rise means potential rise from the battery.
Yeah,
20 volt.
Yeah, 20 volt. Okay, but we must remember to subtract off the potential drop due to the internal resistance. There's an internal resistance, right? It's not a perfect battery. Remember what's internal resistance?
It's the energy loss inside the battery before it can be distributed to the rest of the circuit.
Okay, so it's due to the make of the battery, right? Inside,
Yes.
okay, the chemical inside. Okay, so whatever. Okay, so in this case, you must, but it's still using the principle number 2, right? The potential rise might equal to potential drop for the circuit involving R2. Okay, so with this, you sub in the values. What can you find? You can find I2, correct?
E minus current multiplied by internal resistance. Are you talking about the terminal PD?
Yeah, correct.
Oh,
Good.
okay.
Okay. Well, okay, you know your stuff. Okay, so next, okay, can you find what is I1?
I1. Oh, using total current equal to total current out. So I1 will be 4 minus 1 equals to 3 ampere.
Okay, that is actually principal number.
1.
Yes, great. Okay, so you have I1. Okay, so with I1, what can you find now?
I1, Ri equals to V. So I can find R1.
Yeah, because R1, can you see, is one of the needed to be calculated, right? Calculate resistor R1, okay? So in this case, you know I1, you can calculate R1 by forming another equation based on principle number 2. Can you see? Okay, which is ignoring R2 now, because the loop will involve in R1.
Oh, that means it's another loop lah.
Yeah.
So it depends on what we want to find.
Yes,
Then we
this
select
is
the
another loop. Okay, so this loop, right, similar. The battery and internal resistance is still there, but the resistor is now R1, correct? So solving this equation, you can find R1 equal 4 ohm. So this will give you your first mark, correct? Of course, the working mark is in front. Okay.
Okay, that means power supply to each circuit component just I squared R.
Yes, very good.
Okay, so
That will be
36
last 2
watt
mark.
and let me calculate. Oh, 12 watt.
Yes, great. Okay, so this is example 5. Any question with the two examples?
No. Okay.
Okay, great. Okay, now we're going to go into something. Actually, you should learn in Sec O level, but I'm going to go through with you again. Okay,
I forgotten everything in O level.
but you know everything I tell you just now.
You learned last week, Mr. Roland Lee taught us.
I'm not Mr. Roland Lee.
Oh, sorry.
Okay, now he's more handsome. Okay, let's continue. Okay, we're going to learn about resistor in series and parallel. Why are you laughing? I know he's more handsome. Do I have to keep on laughing? Okay, so in this case, resistors in series and parallel. Okay, so secondary school actually you learn before. I'm going to go through you again. Look carefully. Okay, parallel circuits. Okay, actually involve just the two principles that we learned just now. For these parallel circuits, remember resistor in parallel. Okay, the current I will be equal I1 plus I2 in this diagram.
Yeah, this is the
Principle
first
number
principle.
or Kirchhoff.
Kirchhoff first law.
Very good. Okay, which imply this.
How come
Hmm?
Why from the first step can jump to the second step?
Okay, you know the current I1, right? That's the current flowing through R1. But the PD across R1 will be what?
Will be what?
I don't know. You tell me.
I don't know, you're a teacher.
You.
Oh, I know. Using R equals to V. That's why you, from principle 1, R equals to I1 plus
Okay,
I2.
you know
can
V
relate.
equal IR, right?
Yes.
V equal IR. So I will equal VR. Okay?
Oh, yeah,
So
yeah.
for, let's say there's no example R1, okay? The resistor R1, so its resistance R1, its potential difference is also V. Why? Because
Resistor is in parallel, they have the same PD.
yeah, has the same PD as the as a battery in this case because they're in parallel, right? So the potential difference across R1 is V. The potential difference across R2 is also V. The potential difference across the battery, of course, is V. Okay?
Assuming no internal resistance.
Okay, so if we are imagining this diagram, right? Okay, replacing R1 and R2, right, with a resistance RC, for example. Okay, so the current through RC will be the resistance, the combined resistance will be I, will be the current through it will be I, and so the current through it is V over RC. It's okay. So using this concept, so the current in the combined resistor will be given by V over RC. The current through the resistor one will be V over R1, and the current through the second resistor V over R2. So combining them, right, the combined you will get this equation. It's okay.
Then eliminate the V, is it because they have the
Yeah, because they're the same, right?
PD.
They are in parallel. So remaining this, you will get this equation.
Oh, yeah, I remember.
Do you remember this?
Okay, then how about
This for parallel, right?
parallel?
Remember?
In series will be the other way around.
Yeah, read series later, okay? Okay. So does it matter how many resistors there are? No, right? This one is for 2 resistors.
Yeah,
If I have 3,
just add one more. Lor.
yeah, so it can be 1 million, right?
Yeah.
Okay, of course it couldn't be, but yeah, the principle is there. Okay? Okay? So you must be very clear about this concept. Okay? The effective resistance, right, is the total resistance caused by the whole network of resistors. So meaning the effective resistance means that it's the resistance of the resistor that is equivalent to the resistance of those individual resistors add together. Okay? So we are finding the effective resistance in this case for a parallel circuit. Okay? Just think of it this way. If your resistor is something that blocks traffic, okay? Okay? If you have two, you can break it into parallel, right? 2 branch, right? Will the traffic be reduced? Will it be faster?
Yes.
Okay, so that is important because the car have 2 lanes to move through, right? So when resistor in parallel, more resistors connected in parallel means more routes for the current to flow, and so the overall resistance decrease. Okay, that's very evidence from the equation, right?
Yes.
Okay, great. How about series? Okay, series we are going to use principle number 2. Okay, in principle number 2, right, there's 2 resistors in series, right, and we know that by conservation of energy, right, the potential rise must be equal to potential drop. It's okay, so E equal to V1 plus V2. Okay, now you want to find the effective resistance of R1 and R2, right? Let's take the effective resistance with RC. That means replace these 2 resistors by 1 resistance. So like the PD across the resistance, right, new resistance will be IRC. Correct? Because the current is still the same. Okay, but for the R1, right, is PD V1 is equal to IR1, and V2 is IR2. Okay, so you want to find effective resistance RC, right? Is you can cancel out the I in this case, and you will get RC equal to R1 plus R2.
Oh, yeah, remembered.
Do you know?
Yeah.
Okay, so this is we started this equation, this equation from principle number 2, right? Instead of principle number 1. We use principle number 1 just now, okay? So yeah, this is a comparison, remember? Okay. So same analogy, if you have two blockages, you expect the traffic to be tougher, right, to go through, right? So in this case, the resistance should increase. Okay, so in a series, the resistance should increase.